Okay, YouTube Nation, this is today we've missed a lot of CNA students such as Sierra Jensen and JC Rosas, right? Jajel?
I'm gonna shout out Campbell, hoping that he watches this video. Doesn't remember how to do the radical simplifying or whatever it's called.
There you go, Campbell. Hopefully you are able to watch this video and learn. Otherwise, JJL's just going to have to show you up on Monday. And that's how it goes. So it's important that when we begin by simplifying radicals that we understand perfect squares, perfect cubes, perfect fourths, things of that nature. So let's grab a list here. And some of you have these committed to memory. Some of you do not, which is fine. But let's at least have a list in front of us. So we have 1 squared is 1. 2 squared? 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? How about 11? 121? 12? 13? 169? 14 squared? 196? Biggie's got this. 15? 225 and 16 squared? 256. There we go. There we go. That's a good grouping to know. All right. We just take 14 and multiply by itself. We get 196. As much as you can commit those to memory, the better off you'll be. Okay. What about perfect cubes? 1 cubed. 2 cubed. 3 cubed. 4 cubed. 5. 125. 6 times 6 times 6. 216. 7 times 7 times 7. 343 and 8 times 8 times 8. 512. Nice work. It's okay, buddy. How about perfect fourths? We will only list a few of these. 1 times 1 times 1 times 1. 2 times 2 times 2 times 2. 3 times 3 times 3 times 3. 4 times 4 times 4 times 4. And 5 times 5 is 25. 625, very good. Very impressive. Now, we're going to try to give you as easy ones as possible. We're not going to try to give you the most difficult ones, okay? We start by simplifying the radicals. Does anybody know a perfect square that divides evenly into 48? 16 does go in. You know how many times 16 goes into 48? So we write the square root of 16 times the square root of 3. Okay? I put the perfect square first. Square root of 16 is 4. So this simplifies to 4 roots of 3. Perfect square divides evenly into 28. So I write the square root of 4 and the square root of 7. So this simplifies to what? 2 roots of 7. Uh-oh, a little bit trickier. Square root of 125. 25 goes in 5 times. 5 roots of 5. What's different about problem number 4? You have a cubed root. So what you have to do then is something has to go off in your mind to where you say, I'm going to disregard this section and I'm going to look at the perfect cubes. I'm going to look at this section right here. So square root of 16, I don't locate those. I locate these, and you can see that 8 goes in. So I have the cubed root of 8 times the cubed root of 2. Cubed root of 8. So I have 2 cubed roots of 2. What's different about number 5? fourth root. I look for the fourths. Do you see one here that divides evenly in 162? 81 goes in twice. Fourth root of 81, fourth root of 2. As JGL said, the fourth root of 81 is 3. Fourth roots of 2. I go back to the cubed root. Do you see a perfect cube that divides evenly in 81? 27 goes in how many times? Folks, if you can't come up with 27, I get it. On your calculator, you're going to have to take 81 divided by 64. You'll find out that doesn't work. You'll take 81 divided by 27, and you will get 3. But you're going to have to do the division on the calculator to come up with it. Cubed root of 27 times the cubed root of 3. Cubed root of 27 is 3, so I have 3 cubed roots of 3. We are going to finish up these next 6 years. So we're going to get through 12, and we're going to take a break. You're going to work on some things, and we're going to come back together. But what's different about the ones on the backside? Now you got some variables, right? So no big deal. What you want to look for is it a perfect square, a perfect cube, or perfect fourth? So this is the fourth root of 625 x to the 20th. Is 625, is that a perfect fourth? What is the fourth root of 625? It is 5. Is x to the 20th a perfect fourth? Is there something you multiply by itself 4 times to get x to the 20th? X to the 5. I apologize for number 8, but the square root should have gone over the whole thing. What do you multiply by itself 3 times to get 27? 3. What do you multiply by itself 3 times to get y to the third? Y to the first. What do you multiply by itself 3 times to get z to the 6th? Z to the second. That's the answer. That's it. We're going to make it more difficult here in just a second. Cubed root of 216. 6. What do you multiply by itself 3 times to get x to the 15th? Now as you look at these bottom 3, a little bit more difficult. Can you take the square root of 32? No. So that's when you decide to break it up into 2 roots. What's the perfect square that divides evenly into 32? 16. So now what do? So I put the 2 over here. Here I list the things I can take the perfect square root of. Here are the others. Can you take the square root of x to the third? No. So I reduce the power by 1. How about x squared? Yeah, so I put the x squared there. So an x has to go over there. Can you take the square root of y squared? Yes. So over on the left are all the things you can take the square root of. On the right, you can't take the square root of. Square root of 16 x squared y squared is 4x y root of 2x. Oh, that's not very nice. Okay, very good. Thank you for taking full responsibility. I do recall the conversation that was had yesterday about how work time would happen and you would do nothing. So thank you for your honesty in that situation. So but in fairness and conversation, I want to be clear that there are different ways of teaching this, and I'm choosing a way. So some people do this. They do 40, and then they start making a factor tree. 2 and 20, and they get 2 and 10, and you get 2 and 5. So you circle the group, so it's 2 roots of 10. Did anybody learn like that? Folks, I don't. For me, I that doesn't connect for me. Okay, so I understand why people do that, but I like to just look at it and say, let's make it into 2 square roots. Is 49 a perfect square? So it goes here. Is x to the 5th a perfect square? No. So I reduce it to, and put a, all right, is y to the 7th a perfect square? So I go y to the 6th, y. What's the square root of 49x to the 4th y is 6? Yeah. Last one. Can you take the square root of 50? Nope. So how do I divide that up? 25 in dos, which is Spanish for 2. X to the 4th. JGL is on a roll. Five x squared y squared 2y. Got Mary. You'll never get into Hogwarts. Hogwarts, Harry. Should we all be Harry Potter for the day? the Dementors. Now we sound like Prison Mike. Ah! Gavin, rumor has it you're taking Hermione to the prom. Is this correct? Okay, very good. All right, good luck with that. All right. So, what about the square root of 8? I'm sorry, 3 square roots of 8 plus 4 square roots of 18. The question is, can we add or subtract those? And the answer is no. In order to add or subtract radicals, the radicand, that's what we call this radical, or the radicand, must be the same. So we're going to do 4 of these together, and then we're going to let you kind of work on that piece. But in this situation, 5 roots of 7 minus 2 roots of 7, you can see that they both have the root of 7. Anybody know what 5 roots of 7 minus 2 roots of 7 is? 3 roots of 7. Just as though you had like terms. As though it was 5x minus 2x, that would be 3x in that situation. Okay? So, example 2 is different because the square root of 45 and the square root of 20, those are not the same. So let's simplify them first. 2 roots of, what's the perfect square divides evenly into 45? So I have 9 and 5. 9 times 5. Great. Minus 5 times, what's the perfect square divides evenly into 20? 4, and I have 5. Notice in this situation that these both now have the root of 5. That's a good deal, right? That's a great deal. Now we know that we're going to be able to subtract them. Square root of 9 is 3 times 2. So I have 6 roots of 5 minus square root of 4 is 2 times 5 is 10 roots of 5. Now, all of a sudden, the square root is the same. I have root of 5 and root of 5. So 6 roots of 5 minus 10 roots of 5. Negative 4 roots of 5. Yep. Similar idea. Number 3, I have square root of 12 and square root of 300. Those are definitely not the same. What's a perfect square divides evenly into 12? So I have square root of 4 times square root of 3 plus 4 times the square root of, what's a perfect square that divides evenly into 300? 100. So I have negative 2 roots of 3 plus square root of 100 is 10 times 4 is 40 roots of 3. Negative 2 roots of 3 and 40 roots of 3. 38 roots of 3. JJL's excited. You're starting to get it, okay? You were confused entering today. We're working you out of your confusion. Negative 3 roots of 6. Can I simplify the root of 6? No, it's done. There's nothing I can do with it. Just leave it. So many times people see it, they're like, well, I'll change it to square root of 3 and square root of 2. No, just leave it. Minus 4 times square root of 54. What do I got? What divides evenly into 54? It's perfect square. 9 and 6. Great. I see I can have the square root of 6 now in both situations. So I have negative 3 roots of 6 minus what? 12. Square root of 9 is 3 times 4 is 12 roots of 6. And I get negative 15 roots of 6. Good work. So, adding and subtracting radicals, the radicand must be the same. Adding and subtracting radicals, the radicand must be the same. Okay? That ends our lesson for today. The answer key is done. We've got about 10 minutes till class is over. Enjoy your weekend. It's beautiful.